So to plot points in 3 dimensions, which we sometimes call space, we need 3 axes, x, y, and z, where this is the typical representation of it. Typically, we have the x-axis go like this, the y-axis go like that, and the z-axis goes vertically, where we label it x, y, and z. And this is the positive x, negative x, positive y, negative y. Up is positive z, down is negative z. So let's say that I wanted to plot the following point. Let's say I wanted to plot 3, comma, let's say 4, comma, and how about something like 5? So let me just open up 5 spaces, each way for each axis. So here's what I'm gonna do. I'm gonna focus first on 3, 4 for x and y. So let me go to 3 on the x and 4 on the y. So 3 on the positive x would be like right there. I'll put a little dot. And then 4 on the y would be like 1, 2, 3, 4, like right there. So what I want to do between these 2 points is I want to form a parallelogram that is going to be resting on the xy plane. Here's what I'm saying. So let me just sort of go dot, dot, dot. And I'm going to try to piece this together where this dot, dot, dot is running parallel to the y-axis. And here, this dot, dot, dot that I'm drawing is going, or at least trying to go, parallel to the x-axis. And eventually, these dot, dot, dots will meet. And let me put a point there. So right now, what I want you to see is that the coordinates of this point where I'm pointing at, that has coordinates 3, 4, 0. But I want 3, 4, 5. So what I have to do is I have to lift up this point up to the sky 5 spaces. So one of the options that you have is to not just draw this point here, but to draw a full-on box where one of the vertices of that box happens to be 3, 4, 5. It's a bit of an exhaustive process, but let me run through this and let's see if you agree with me. So let's go to 5 high. 1, 2, 3, 4, 5. Now watch what I do. From here, let me do this. Let me go from here, from this X point. Let me draw up toward the sky, parallel to the Z-axis, and I am gonna stop when from here I can draw parallel to the X-axis, and I have a vertex there. And now maybe what I can do now, here, what I can do is I can draw parallel to the Y-axis, and I will stop when from the Y-axis I can go upwards and they intersect. And maybe now what I can do from here is I can go like this, and I'll stop when this one here drawn parallel to this one, they sort of meet right there. And then from here I can go up toward the sky and boom, this point here, that is the one that has coordinates 3, 4, 5. Was it necessary to draw the entire box? No, and by the way, I didn't draw this one here, like that, dot, dot, like that. So the whole rectangular prism is there. The box is all there, and one of these vertices happens to be 3, 4, 5. Was it absolutely necessary to draw the entire thing? No. Maybe your professor would have been okay if from what we had earlier, which was something like, I think what we had earlier was this here, and then 1, 2, 3, 4, 5. Some professors are okay if you just like measure this height and apply it here and eyeball it, right? Some professors are okay if you just eyeball it, where it's 3, 4, 5. So that there. Some would prefer that you draw an entire rectangular prism and just emphasize one of the vertices of it. So regardless of the method that your professor prefers, this is one way of graphing a point in space. Let's try another one. Let's say you wanted to plot -2, 6, -4. So we can draw the X, Y, and Z axis, and let's just go a few spaces each way. I'll put a little more this way because I know I'll need the room. That should be okay. And then let's just go like this because I got to go down quite a bit. So let's start off with the X and Y. So let's go -2 and 6. So -2 for the X-axis takes you back. -2 is like right there. And then +6 for the Y, go all the way to 6, I believe that's right here. And now from these two, let's draw that parallelogram. So we can go parallelogram like that. Let's build this together like this, okay? Little parallelogram action. So I'm right there. And now what I need to do is I need to elevate this point, or rather lower it 4 spaces, right? Because it's -4. So I know that -4 is like here. So this height could be just essentially measured there very loosely. So I know it's going to be down here. But let's just continue with the idea of drawing a box. So let's go to -4 on the z-axis. 1, 2, 3, 4. Put a point there. And what I can do is I can sort of form many of the sides of the rectangular prism, which is just a fancy way of saying box. You see that? So I can start drawing my box. I could actually do this one as well. Go 6 spaces this way and just shoot straight up. So we do rely a lot on drawing parallel to some of the axes, X, Y, and Z. And now from here, let's finish this off. So maybe what I can do is I can draw this beam parallel down here like that. And then I'll stop when it's directly beneath this one so that these can be joined, something like that. And if you want, from here, you can, it's just like art class, right? It's like art class, like that. And actually that was too much. Right? It shouldn't be like that, because from here, I should be drawing parallel to the x-axis like that. And then a little bit more, and then it should go straight up. So this part in orange here, that was excess. It shouldn't be there. Right? It shouldn't be there. And now you can see your box there, right? You can see your box. You have all 6 sides of this prism, but we wanted this point here. So it was -2, and then 6, and then down 4. So our point, which you should emphasize above all of the others, is right there.